Okay, come back. Who? Who's in the back? Um, oh, yeah. Okay. So just a couple of comments on lab reports before we start. So I have general comments. So Monday group just got, please, can I have your attention? You're a very chatty group. I like that, but let me have your attention. Okay, so Monday group got their second lab report. Wednesday group will get it on Friday. But I just have general comments. Again, please make sure that your format is as requested. For example, if you have a table, don't split it between 2 pages. Make sure that the font and the size of that table fit on 1 page. Okay? So formatting. Please pay attention to formatting. Title. Some of you are doing a good job with the title. Others are either very brief or too descriptive. So you don't want 3 sentences in a title. And at the same time, you don't want a title that says precision and accuracy. So make sure your title is concise yet descriptive at the same time. So pay attention to title. Second, in questions, if there is a table that you're asked to put in a question, it has to have a table number and a table title, even though it's not in the results section. It's a table. So tables and figures, no matter where they are, they have to have a title and a number. Appendices, there's still some confusion about the difference when we say list appendix versus attach appendix. So most of you are getting it right, but there's still some confusion. When we say list appendix, it doesn't have to be on a separate page. After your questions or references have a section that says appendices, then name them and give them the title only. On the second page, you attach them with the label on top. Okay? So list them, then attach them. Okay? And then everybody has comments in their lab report. So Cindy and the TA that raised the question leaves very detailed comments. This to help you for the future lab reports. Please read the comments so that you don't have the same error over and over. Okay, we want you to do well in these lab reports because, again, more than 1/3 of the grade is on lab reports. So we want you to be successful. And don't be shy coming to us and ask questions if you're uncertain about anything. Okay, this is the writing intensive class. We want you to succeed in writing. We're not here to judge you. We're here to help you learn. Remember that. Okay. All right. Any questions? Okay, no questions. How was the quiz? Easy? Is that Will? Your enthusiasm today is great. 10 over 10. Well, I hope it was fine. Any questions particular to the quiz before moving on? Any comments? No? Okay, everybody's going to get an A? All righty, good deal. Let's pick up where we left off, please. We have like 10 minutes, Alex, and then you're free. All right. Let me just review a little bit, introduce resolution, and we'll finish on Friday. Okay. Name examples of adsorption chromatography. You reviewed for the quiz, so you should be able to list some of that. Remember, participation points are very easy points to get to. They can get you from a B- to a B or an A- to an A. Talk to us. Alice?
Yes, and there's hydrophobic interaction, ion exchange.
Okay, so hydrophobic interactions, so that means hydrophobic interaction chromatography, affinity chromatography, ion exchange chromatography, they are all forms of adsorption chromatography. Perfect. What molecular weight interaction between solute and stationary phase are involved in size exclusion? Phase. None. Size exclusion. None. It's separation based on size. Ion exchange. Will. More enthusiastically?
Electrostatic.
Yes. Yes. Hydrophobic interaction chromatography? Hydrophobic interaction chromatography? Yes, Sammy? Hydrophobic interactions. Okay, affinity chromatography? Affinity chromatography? What types of bonds? Legends? What? Yeah, okay, Regina gets +2, but not the correct answer. Anna? You don't know that?
Yeah, I was thinking of like.
We get to +2 no matter what.
Yes, like I was thinking of like so one question where you didn't want us to say covalent bonds, or it would be like all the other bonds.
All of the other but covalent.
Yeah.
Hayden?
We had the same though. But
Adele? You?
hydrogen bonds.
Hydrogen bonds?
No, I've got it written in my notes. Takes advantage of unique interactions.
Takes advantage of unique interaction. And these interactions could be hydrogen bonding, electrostatic interaction, hydrophobic interaction, van der Waals interaction. So any type of molecular interactions can occur in affinity that they are very specific but no covalent interaction. Okay. What is the difference between cation and anion exchange chromatography? Jason.
Well, it's the difference in your column, so whether it's positive charge or negative.
So when it's a cation exchange chromatography, your stationary phase is positively charged or negatively charged? Negatively charged. Good recovery. Yes, cation exchange meaning we're exchanging cations, so the chromatographic column should be negatively negatively charged. So the opposite is true for anion exchange. So how do you increase the strength of the mobile phase in reverse phase chromatography? So it's one of the questions you had in the quiz. Paul? Decrease the polarity in reverse phase. Yes, correct. So in reverse phase, your mobile phase starts as a polar, and as you increase the strength, the polarity decreases, so you add organic solvent. What about hydrophobic interaction? Decreasing the concentration of the salt. That means making it, starting with a high concentration of salt and then decreasing it over time until it's only water. Okay, what else do we have? Ion exchange. Yeah. Changing the pH. You can either increase the pH or decrease the pH depending on whether it's anion exchange or cation exchange. Another way of changing the strength, increase salt concentration. Yes. In affinity chromatography, well, that is very specific. Yes, you can increase the ligand in the mobile phase so that the solute is interacting with the ligand in the mobile phase. But another way that is not specific, what can you do? Yeah? Change the pH of the ionic strength. That is a non-specific way of changing the strength in affinity chromatography. Okay, what is the order of elution in hydrophobic interaction chromatography? So the most hydrophobic comes out first or last? The most hydrophobic in hydrophobic interaction chromatography. Last. Because remember, chromatography is all about interaction with your stationary phase. No interaction, no separation. So the more interactions you have, the more it stays on the column. In ion exchange, the ion with the highest valence versus lowest valence. Which one will do it first? Yeah? Lowest valence. So the more ions you have, if it's a cation or an anion, the more ion, the more charge it has, the more net charge it has, the more interaction it's going to have with the column. Size exclusion, what's the order of elution? Yeah? Large elute first, because it's based on the pore size of your stationary phase. If it's a large molecule, it won't go through the pores, so it won't be delayed. If it's a small molecule, the smallest it is, it's going to go into all of the different sizes of your pore size and be delayed. Okay, great. So you are set to go with chromatography. This is all you need to know. Bye. Okay, now I have few minutes left. Huh? Okay. This is the cream on top for chromatography. If we don't separate the peaks, there is no use of chromatography whatsoever. So we need to learn how we can separate the peaks. And what do we do to separate the peaks? So that we can first detect them, identify them, and then quantitate them. If we cannot separate two compounds from each other, it's really going to be hard to identify unless there is an MS attached to it that can, even if you have coelution, MS can help you identify. But it's better for identification to have separation. If you want to quantify, you need two separate peaks, so you can get the area of each peak separately, so you can quantitate. So we really, in chromatography, we have to develop a separation. We have to guarantee separation to the best of our ability. So how do we do that? How do we do that? First of all, we need to know things about our components. So let's say caffeine. What do we know about the caffeine? Small molecule. It is soluble in water. It is also soluble in nonpolar organic solvents. It is an alkaloid, so it can interact via nonpolar interactions. So what do we know about the component will help us determine which stationary phase to use, which, is it going to be HPLC, is it going to be GC, what stationary phase, what mobile phase. So we need to know as much as we can about the chemistry of the components we're analyzing. And how many components we need to resolve? So are we looking at carotenoids? So there are multiple carotenoids in the sample. Are we able to separate them, to quantitate them? Are we looking at different phenolics? There could be infinite number of phenolics that we want to separate and quantitate. So what are the phenolics, for example, that we are quantitating or separating? How many are we looking for? Like sugars, how many sugars there are, which ones are we looking for? So knowing the different components and knowing how many of these particular components we have. So do we expect 5 peaks? Do we expect 10 peaks? Do we expect infinite number of peaks? Okay, what degree of resolution? Like, do we really need to be very much separated, or it's okay if they're not separated? We're, like in this case, if they're not separated, but we can see that there are 2 peaks, and I have a detector that allows me to identify this peak from this peak without being separated, I don't need to quantitate. So if I don't need to quantitate, and I have a detector that allows me to tell the difference between this and this and identify, then that's okay, I'm satisfied. I don't need to spend more time separating these 2 peaks. But if I want to quantitate, it's so hard to integrate and get the correct area to get the concentration when it's not fully separated. Okay? So it really depends on the purpose. So I need to determine how much do I need this to be very well resolved or separated from each other. So again, is it qualitative, is it quantitative? I am after identification, or I am after quantification. So oftentimes, and I think Gary mentioned that in his lectures on GC, when you are given a problem and you want to separate components in your sample, you go ahead and you extract your sample and you want to separate it. Oftentimes, the first thing you do, what do you do to know what method to use? The very first thing, and Gary said that in the GC lecture. What do you do when you have a sample and you want to identify certain components? The first thing you do is what? To choose a method.
Is it to choose non-polar stationary?
Before we go there even, we don't know where to start.
Read about it.
Read about it. We just read about it. So we see somebody must have looked at it before us. It's very hard to find a project where nobody has done it before. So I'm sure somebody had done it before. So the first thing you do is you go and look what other people have done. You'll see that the same components might have been analyzed with different modes of analysis. So some people use reverse phase, other people use normal phase, some used ion exchange, some used hydrophobic interaction chromatography. So the choice of the method often comes with what you have available in the lab as well. What do you have set up in the lab? What columns do you have? What detectors do you have? So then you can also choose a mode of separation based on what you have, what's comfortable for you to use, and what's also compatible with the types of sample you have, with the chemistry of the sample. So we start with what is published, and then we go to what we have in the lab or what we can obtain in the lab, because you'll see that for the same molecule or set of compounds, you can use different types of chromatography. So if we look at molecules that are water soluble, but they are ionic, they have charge, you can actually separate them with reverse phase. You can separate them with reverse phase ion pair, where you block the ion and they become interacting via nonpolar interaction. Or you can separate them by ion exchange. So you can see that the same molecules can be separated by different modes of separation. Okay? So there might be multiple answers that are correct. For the quiz, if you said reverse phase is correct, if you said normal phase, it would have been correct too. It depends how you explain it. Okay. All right. Goodbye. I'll see you Friday.
Yeah, I wanted to ask you exactly the same question. Is this supposed to be reverse or normal?
Yeah.
Because I put both of them, because like
Yeah,
it wasn't
but you
clear
can
what our
explain,
compound is,
yeah.
But then I said like it needs to be this way.
Yeah.